We're going to define what log base a of x means. It's a quantity representing the power to which a fixed number a must be raised to produce a given number x. Okay. The most important thing is that you remember this right here. This is what you need to know the whole time we're doing logarithms, is right here. Log base a of x equals m means a to the x equal 8. Oh, wow, I so totally typed that wrong. A to the m equals x. Wow, okay. Let me fix that. A to the m equals x. And so basically, if I can't solve it or do anything with it as a log, I'm going to switch it to an exponent. And if I can't solve or do anything with it as an exponential equation, I'll switch it to a log equation. So I need to know this relationship pretty well. I do need to memorize this. So this says log base a of x. So my base here, this a, becomes the base of my exponent. Those are both the bases. And then the x and the m just kind of switch places here. So this on this side, the x is with the m. On this side, the equal sign, and on this one, the m is on the other side, the equal sign. When I switch it to an exponent, they switch places. The m becomes the exponent with my base, and this x goes to the other side of the equal sign. Okay, so we're going to be working on that in just a minute. But first, we just kind of want to use this relationship to simplify or to solve these basic logarithms. And again, it says, the definition says, the quantity representing the power to which a fixed number a, so in this first case, this would be 2, this first case here, 2 must be raised to produce, so I need to, so basically it says 2 to what power, sorry, this is a little question mark, 2 to what power equals 32. And so that's what I'm trying to solve, and that's what this says, raised to produce a given number x. So 2 to what power equals 32? And that kind of uses this definition that we have over here. 2 to what power equals 32? So can anyone tell me 2 to what power equals 32? Yeah, good. It's 5. So this equals 5. And in case you need to know, right, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's 5 2s. So it's 2 to the 5th power. So the next one, I'm going to do the same thing. Again, it's 2 raised to what power? So 2 to what power equals 1? So 2 to what power equals 1? 0, yep. So this one equals 0. Remember, anything to the 0th power always equals 1. So if it's some log that equals 1 here, like 2 to whatever power, or whatever to whatever power equals 1, that power will always be 0. It's the easiest way to kind of think about it. And this one's a little harder. So this says, again, we're doing 2. We're sticking with 2. 2 to what power equals 1/8? So what type of exponent is going to give me a fraction is basically what it's asking. 2 to what power equals 1/8? Should be getting answers from more than one person, by the way. Okay, so let's kind of go over here and talk about this one. It doesn't look like many people know this one. So if I have a table, I'm just going to kind of make a table here, and I'm going to say 2 to what power, and this is going to be my power, so let's not do 2 to what power, let's just do 2 to the x power. 2 to the x power, right? And I have, let's start with 2 to the third, and start with x equaling 3, and then 2, and then 1, and then 0, -1, -2, and see what happens. So what's 2 to the third power? Let's start there. 2 to the third power is what? 8. Good. And 2 squared is? 2 squared is 4. 2 to the first power is 2. So I kind of want to talk about, before we go on here, what's happening every time here. Well, what's happening to get from 8 to 4 and 4 to 2 is I'm dividing by 2. Is that correct? Right? So to get to the 0th power, just kind of show you how this works. To get to the next one, I'm still going to divide by 2. Every time I'm just dividing by 2. It's the same pattern. It's a pattern. It's never going to change. So 2 divided by 2 is 1. And that's why 2 to the 0th power is 1. It doesn't matter what my base is. If it was 3 to the x power or 4 to the x power, it'd be divided by whatever that number is. So here I would always still get 1. Then I'm still, because it's still the same power, I'm still dividing by 2 here and here all the way down. 1 divided by 2. So 2 to the -1 power would be 1/2. 1 divided by 2. And 2 to the -2 power would be 1/4. So what, let's go back to this answer here. This answer says, or what I'm asking you anyways, says 2 to what power equals 1/8, and no one's been able to answer that yet. Can someone tell me what that answer is? Yeah, Jade. Jalen. So how I kind of think about it is, if it's a fraction, notice up at the top part up here, they were all whole numbers over here, whole numbers here, and here they were all positive numbers, right? And then once I get down here and my x becomes negative, what happened to my numbers on my y side? Well, they become fractions. So a negative exponent gives me a fraction. So I know that when I have a fraction as my answer, my exponent's going to be negative. And then what do I, and then what I do is I say 2 to what power gives me 8? Well, that's 3, so that should be -3. It's kind of how that works. Okay, so I know JJ's already answered this. Good job, JJ. But I'd like you to go ahead and do the next, well, there's 9 of them. 9 problems. Here we go. Just going to do these really fast. So this says basically 10 to what power equals 1,000. Well, that's 3. And then 3 to what power equals 81 is 4. 7 to what power equals 49 is 2. 5 to what power equals 1/5 is -1. 8 to what power equals 1/64? Well, that's -2. 5 to what power equals 1/25? That's -2. 7 to what power equals 7? Well, that's 1, because just the number by itself is always to the first power. And then this one says, H says 6 to what power equals 6 to the 9th? Well, the exponents would have to be the same, so this would be 9. And then the last one is a little bit harder. It says 100 to what power equals 10. So the question is, what do I do to 100 to get 10? Well, I take the square root of it. And what's square root as a exponent? That's 1/2. So just, I know we kind of talked about it before, but I'll write the rule down. It says, if I have the nth root of a to the m, that equals a to the m over n. So if I have the square root of 100, that would equal 100 to the 1/2. 100 to the first power divided by 2, the square root. So that would be 100 to the 1/2 power, and that equals 10. Okay? So moving on to the next section, and basically is just how to rewrite it. I want to rewrite it, and I'm going to use the rule that we got from the very beginning that says log base a of x equals m. Sorry, I'm trying to remember the order that I had it up there. If and only if a to the m equals x, right? So basically what I want to do is I want to go from this form to this form. So it's in logarithmic form. I want to be able to rewrite it as an exponential form. And that's it. So my bases are going to stay the same. So this is y equals log base 3 of y. So my base for this one is going to be 3, because my bases are the same. This stays the same, log base 3, and 3 is the base of my exponent. And then this goes here, and this goes on the other side. So I should have written my 3 a little lower, sorry. 3 to the y equals 5. So that's all. I'm just switching the places of the y and the y and the 5, and the 3 becomes the base of my exponent. So once again, what's the base of my exponent? Well, the base of my exponent is a. Okay, is a, and then the other two switch places. So the other two switch places, right? So this is going to become a to the -2 equals 7. And so my base of my next exponent is going to be the base of my logarithm, which is b. And then these two switch. So I have b to the a equals d. And you guys should know how to write this into the chat box, right? So this would be b caret key to the a equals d, right? That caret key means exponent. So I think all of you know how to do that. So we're going to go ahead and give you a few minutes to go ahead and rewrite these 6 problems. Please make sure if you have a question that you're asking it, please. Thank you. Okay, so almost everybody who's put something into the chat box, well, actually everybody who's put it into the chat box has been correct. So here we go. We've got, let's see, 8 to the y equals 10. And then the b should become r to the t equals c. And then c to the 8 equals m. D is b to the 23rd equals n. M to the a equals p. And then the last one says e to the negative 0.0111 equals 0.989. Okay. Is there any questions on that? Is everyone okay? Does it feel okay to do this? Okay. So let's go ahead and go to the next little section. So the next one, we're doing pretty much the same thing. So if I have log base a of x equals m, right? If and only if a to the m equals x. Only this time I'm going from here, I have it in exponential form, and I want to be able to write it as an exponent. So I'm doing the same thing, right? So my base of my exponent becomes the base of my logarithm, and then these two switch places. So I have log base 2 of 8 equals x. Okay, same thing on the next one. The base of my exponent, which in this case is y, becomes the base of my logarithm. So I have log base y. And then these just switch positions. Log base y of 4 equals negative 1. And then the last one, my base is a. So I have log base a of c equals b. Okay, so I'm just doing the opposite this time. And then when I put this into the chat box, you guys, because it's easy to do exponents with the little caret key, you can't do a base. So what we've decided to come up with is we just do this log base, and then in parentheses we put our base. So log base a of c equals b. So whatever our base is for our logarithm, we're just putting it inside parentheses so we know that that's our base, because there's no way to make a subscript in the chat box. So this is just how we kind of decided and worked out between several classes on how to write a logarithm into the chat box. So this one would be log parenthesis y of 4 equals negative 1. So just make sure you're putting your base inside the parenthesis. I hope everyone's okay with that when we do this. So here is the next 6 problems. Here's my base of my exponent. So this becomes log base 8 of 2 equals 1/3. Here's the base of my exponent, so it becomes log base 10 of 3 equals 0.4771. I just want to kind of talk about this one for a minute, because if it's log base 10, we haven't really talked about it a lot, but that's like the common logarithm. So I could actually also write this as log of 3 equals 0.4771. If it's log base 10, I don't have to have the base 10 there. It's like writing 1x. You don't have to write the 1 with it. If it's a log base 10, I don't have to write the 10 there. And we're going to talk more about that in a few days. I don't remember which lesson it is, but we will talk more about this one. So this would be log base 10 of 2 equals 0.3010. Then we have log base m of r equals n. Log base p of q equals p, nope, sorry, equals t. There we go. And then the last one is log base e of 20.0855. That equals 3. And this is another special logarithm, log base e. It's called the natural logarithm. So I can actually write that one as ln of 20.0855 equals 3. And we'll talk about that one later also. Either one is correct, okay? So here we move on to the last little section here. And basically we're going to be doing a little bit of solving, okay? So it just says solve for x. And basically, if I can't solve it as a logarithm, I'm going to switch it to an exponent. And for now, we only have logarithm, so we're just going to kind of switch it and see if I can get what the answer is. I think it'll make sense when we do it. So if I have this, if I write this one as an exponent, I get 2 to the negative 3 equals x. So x is going to equal 1/8. I think that's correct. Yeah, 2 to the negative 3 is 1/8. Okay, so see how switching it to a logarithm made the answer just become a little more apparent. And the same here. I don't know what my base is, but if I rewrite it in exponent, I have x squared equals 16. So, right, I can square root it. So x is going to equal 4. In this case, in logarithms, let's just say we only want the negative answer. Mostly we only want the negative answer, but a base can't be negative. So there may be some cases if it's a logarithm, if it's quadratic to solve, and we're going to get to this a little later, but I want to put this out there that you know, when I have a quadratic, I usually have two answers, the positive and the negative. Sometimes the negative can be a viable answer, and we'll talk about that when it's possible. For now, it's not. I cannot have a negative base. Therefore, it can't be the negative 4. It's only the positive 4. Okay? And then number 3. Now, you could put this into a calculator, log base 10 of 1,000. It'll give you an answer. Or, I think we pretty much know this. If I switch this to an exponent, this says 10 to what power equals 1,000. And I think you guys already know that's the third power, right? 10 times 10 times 10, okay? And then for the last one, it says 4 to what power equals 1. Well, we already know that x has got to be 0. Anything to the 0th power equals 1. So I think there's 3 problems. Oh, no. 6 problems here for you guys to answer and find the answers for. Here we go. So this first one would be 4 to the 3rd power equals x. So if I'm going to solve that, x equals 64. The second one says 2 to the x power equals 32. And we kind of already talked about that. But x equals 5. When we did 2 to what power equals 32? Same thing. So the third one, C, says 5 to the x power equals 25. So 5 to what power equals 25? Well, that should be squared. Number D, letter D, number D. X to the first power equals 12. Well, what to the first power equals 12? Well, that would be 12. The letter E says x to the 1/2 equals 7. So there's a couple different ways you can think about this. You can remember that 1/2 means that's the square root. So I can say the square root of what number equals 49? Or I can say, well, how do I undo the 1/2? Well, I multiply by 2, right? 2 times 1/2 is 1. And if I square one side, I'm going to square the other side. So x equals 49. I kind of like that way to think about it. And then the last one says 3 to the negative 2 equals x. So x is going to equal 1/9. Okay, so that's it, which is just a quick introduction to logarithms. We're going to get more in depth in the next, like this week, basically. We're going to just do logarithms. So you have a Delta Math assignment. If you do it right now, and you should be able to get it done by the end of class.